I'm Anil Kumar, and with the help of few examples, I hope I will be able to show you how composition of function affects the graph of a function, right? So here the question is, given the graph of y equals to f of x and the function g of x equals to minus 2x, sketch the graph of f of g and g of f. As you know, whenever we do composition of functions, we normally get very different graphs for f of g and g of f. Now I'd like you to pause the video, sketch these two graphs and check it for yourself. Now let's try to do it. So first let us do f of g. So when I say f of g, it means more. It means f of g of x, correct? Now in our case, we are given f of x as the function graph. So this is f of x for us. When I say f of g of x is minus 2x, I could write this as f of minus 2x. Now f of x is given to us, we need to sketch f of minus 2x. What does that mean? It means that the given function is getting transformed, and the transformation is reflection on y-axis, horizontal compression by a factor of half. So these are the two transformations which take place. So first one is reflection, that is horizontally on y-axis, and the other one is horizontal compression, right? By a factor of half, correct? So that is what it is. So whenever you do f of g, then what is the effect? Effect is horizontal. This is kind of very critical to understand, right? So now let us sketch and see for ourselves how will it look like. So when I do f of g, I have to reflect it and then compress it. So let's do it in two steps. First, let's reflect each point on the y-axis. So minus 2 will go to plus 2, and this will remain there itself. So let me join them first. So we'll do it in two steps, okay? So I'm doing this first step, okay? So and then this point, which is at 2, will now appear at minus 2, correct? So from here, we have going like this. This one is at 4, will now appear at minus 4, so we'll go there. So we'll have, that is the reflection on y-axis. So the whole graph is reflected on y-axis. Now we'll do horizontally compressed by half. So each and every point will be brought half the distance closer. That is what we mean when we say compress it horizontally by a factor of half. So minus 4 should appear here at minus 2. So this point moves to minus 2. Minus 2 moves to 1. So we get this line here. Do you see that? Now 0 times anything is 0, so it remains there itself. So this point line is common. Now here 2 gets closer and comes to 1. So that is this point. So the result is the shown graph here. You will see that its domain changes, right? That is the effect of horizontal compression and reflection. So that is our graph, correct? So that is how we could write it. Let me write down the points here. Let's say the original points for us were A, B. Let me write down these points as A, B, C, and D. Then the reflected points for us will be, so the A point moved to the right side. So we have this as A dash. And B dash remains same. So B dash, C dash, and D dash, right? So that becomes the graph for f of g, right? Now let us see how to sketch the graph for g of f. Now g of f is equals to g of f of x. Now g is given to us as minus 2 times x. So what we get here is minus 2 times f of x. Now that means what? It means that the f of x function will be reflected on x-axis and vertically stretched. So the effect is vertical in this case. Do you see that? So here the effect is vertical. Both are vertical. So reflection on x-axis, which is vertical in nature, and the second point is vertical stretch by a factor of 2. So both are vertical in nature. That's kind of important to understand, and this is what I want to emphasize. So let's look into the original graph. If I reflect -2, it remains there. If I reflect point B, which is at 2, it comes to -2. This is all vertical, right? So 1 will appear at -1, 2 will appear at -2. So the graph which I expect to have, this is my first part, then I will do vertical stretch for this graph. Now if I vertically stretch this, that means every number gets multiplied by 2. So -2 becomes 4, 1 becomes -1 becomes -2, and this is -2, it will be 4. So what we have here is like this. 0 remains at 0, right? 0 times anything will be 0. So that point is constant. So that is the graph, correct? So this is the effect of G of F. Do you understand? So these are our points. Let me call them as A double dash. Now this is B, right? B double dash, C double dash, and D double dash. The second transformation. So whenever we do F of G, the transformation is horizontal in nature, and when you do G of F, it is vertical in nature, and that is what you need to understand from this example. I hope that helps. Thank you, and all the best.